Wiring. Every brain is wired differently. Michael Jordan's athletic failures are puzzling, don't you think? In 1994, one of the best basketball players in the world, ESPN's greatest athlete of the 20th century, decided to quit the game and take up baseball instead. Jordan failed miserably, hitting .202 in his only full season, the lowest of any regular player in the league that year. He simultaneously committed 11 errors in the outfield, also the league's worst. Jordan's performance was so poor, he couldn't even qualify for a AAA farm team. Though it seems preposterous that anyone with his physical ability would fail at any athletic activity he put his mind to, the fact that Jordan did not even make the minor leagues is palpable proof that you can. His failure was that much more embarrassing because another athletic legend, Ken Griffey Jr., was burning up the baseball diamond that same year. Griffey was excelling at all of the skills Jordan seemed to lack, and doing so in the majors, thank you. Griffey, then playing for the red-hot Seattle Mariners, maintained this excellence for most of the decade, batting .300 for 7 years in the 1990s and at the same time slugging out 422 home runs. He is, at this printing, 6th on the all-time home runs list. Like Jordan, Griffey Jr. played in the outfield, but, unlike Jordan, he was known for catches so spectacular he seemed to float in the air. Float in the air? Wasn't that the space Jordan was accustomed to inhabiting? But the sacred atmosphere of the baseball park refused to budge for Jordan, and he eventually went back to what his brains and muscles did better than anyone else's, creating a legendary sequel to a previously stunning basketball career. What was going on in the bodies of these two athletes? What is it about their brains' ability to communicate with their muscles and skeletons that made their talent so powerful and so specialized? It has to do with how their brains were wired. To understand what that means, we will watch what happens in the brain as it is learning, discuss the enormous role of experience in brain development, including how identical twins having an identical experience will not emerge with identical brains, and discover our very own Jennifer Aniston neuron. Fried eggs and blueberries. You have heard since grade school that living things are made of cells, and for the most part, that's true. There isn't much that complex biological creatures can do that doesn't involve cells. You may have little gratitude for this generous contribution to your existence, but your cells make up for the indifference by ensuring you can't control them. For the most part, they purr and hum behind the scenes, content to supervise virtually everything you will ever experience, much of which lies outside your awareness. Some cells are so unassuming they find their normal function only after they can't function. The surface of your skin, for example, all 9 pounds of it, literally is deceased. This allows the rest of your cells to support your daily life free of wind, rain, and spilled nacho cheese at a basketball game. It is accurate to say that nearly every inch of your outer physical presentation to the world is dead. The biological structures of the cells that are alive are fairly easy to understand. Most look just like fried eggs. The white of the egg we call the cytoplasm. The center yolk is the nucleus. The nucleus contains that master blueprint molecule and newly christened patron saint of wrongfully convicted criminals, DNA. DNA possesses genes, small snippets of biological instructions that guide everything from how tall you become to how you respond to stress. A lot of genetic material fits inside that yolk-like nucleus. Nearly 6 feet of the stuff are crammed into a space that is measured in microns. A micron is 1/25,000th of an inch, which means putting DNA into your nucleus is like taking 30 miles of your favorite fishing line and stuffing it into a blueberry. The nucleus is a crowded place.